So there are no homework questions mainly because, well, we didn't have any homework. We haven't had any homework from chapter 2 yet, so not able to quite ask questions yet over it. And what we're looking at today is writing transformations of quadratic functions. The lowest point on a parabola that opens up or the highest point on a parabola that opens down is the vertex. And the vertex comes in the form of h comma k. Now, the reason we call this here a parentheses x minus h squared plus k vertex form is, well, because it contains the vertex. In a lot of ways, whenever we talk or name something in mathematics, they call it exactly what it is. And most mathematicians, it seems, do not have very much creativity when we come to naming things. Because when we talked about the equation of a line in point-slope form, well, we called it point-slope form because it contained a point and it contained the slope. Slope-intercept form contained the slope and the y-intercept. So it's just exactly what it is. And that's the way that we have this here. Now, we did talk about these parts yesterday too, that A indicates a reflection across the x-axis and a vertical stretch or shrink. H indicates a horizontal translation left or right. And K indicates a vertical translation up or down. Now, I'm going to give you these here again because we had these last time and I know you weren't in here last time, so I'm going to write these out so we see them. When we talk about a horizontal translation, to apply that transformation, we're going to use the notation f of x plus k to apply the transformation to the function. For whatever left or right movement we have is the value of k. Then we also have, that's the next one. This is f of x minus h. Yeah. Vertical translation. Now this is our f of x plus k. So inside the parentheses is our left-right, kind of just like the function, tells us left or right. Outside is our up or down. So this here is our left or right. This is our up or down. And this notation helps us be able to apply these transformations to the given function. Now we also have our reflection. Across the x-axis is given to us by the notation negative f of x. Now if it's across the y-axis, it's f of negative x. Then we also had our vertical stretch or shrink, which is our a f of x. And our last one is our horizontal, L, stretch or shrink. And this is our f of ax. And we use these notations to help us be able to apply the function. We plug in the given information and apply it to the function to apply each one of these here. Now the only one that has a little bit to it is horizontal stretch and shrink. We have to remember to flip the value just like we did yesterday. Because what we're looking at today is actually applying these transformations to a given function. Moving it up, down, left, right, stretch, shrink. And we have these here. Now let G be the graph. Let the graph of G be a vertical stretch by a factor of 2. So there's our first transformation. And a reflection in the x-axis, followed by a translation of 3 units down of the graph of f of x equals x squared. Write a rule for g of x, so we want to find the function. Yes. And identify the vertex. Right, so we would say f of x, because I'm going to write it out so we see it, but again, yes. Value of a is 2 times f of x. But did we do anything to the x in our f of x? No, it's still just f of x, which means I'm going to replace f of x with what it's equal to. In this case, it's equal to x squared. So we're going to have 2 parentheses x squared. Now we need to multiply them together. 2 times x squared is vertical stretch by a factor of 2 is done. We did that one there. Questions on this so far? We good with this here? Now we do need a way to name this, so I'm going to call it h of x. But again, the naming is not as important as the function itself. So we feel comfortable with the vertical stretch of 2. Now the next one was a reflection in the x-axis. So this is our negative f of x, but we're not talking about the function f of x anymore. We're talking about h of x. So we're saying negative h of x. Well, it's still just h of x. I didn't change anything inside those parentheses. It's still just an x. So that means I'm replacing h of x with its. So we'll have negative parentheses 2x squared. So the reflection across the x-axis is defined as, for us to be able to do a reflection across the x-axis, is our negative f of x. Now we didn't use f of x because f of x is just a way to name the function. So instead of using f of x, we're talking about h of x because it's being applied to the function here. Yeah. Good question. Any others? So we're good with up to this point, yes? Now again, the reason we put the parentheses, we didn't really need them. Well, we need them on the first one to do the multiplication of 2. We need it here because now we're going to distribute the negative, giving us negative 2x squared. Now I need a way to name this one. What do we want to call it? G of x. So we did our reflection. So we have one more transformation, which is two units down, yes? So the 2 units down would be our g of x plus k. So we still have g of x. We need to plug in the value of k. Well, the value of k is 3. And it would be negative 3 minus 3 because we're going down. If we were going up, it would be plus 3. Now, g of x is still just g of x. We didn't change anything about it. It's still just x inside the parentheses, yes? So that means I can replace it with its function, which is negative 2x squared. And then we have the minus 3. Right, almost. We just need to drop the parentheses, telling us that we have 2x squared minus 3. And we call it z of x. But again, what we call it's not as important as the function itself. Questions on this here? Now the other part to this was to identify the vertex. Vertex is our point h comma k. And the vertex is the biggest or smallest point. It's one of those two. Oh,
So I got a question.
yes.
So if it would have been across the y, would it just have been the same thing that we would do?
It would have come out a little differently because if we said y, it would have been h of, which would mean that we have to replace the x and x, the negative 2, or the 2x squared with negative x. So we would get this here. So it's a little bit different because the negative would not come out front. We would leave it as this here. Does that make sense?
Oh, so it just be that, and then minus 3.
Then we'd have minus 3, yes. Yeah, you're good. Yeah, that's a good question because there is a little bit of a difference between x and y axis and how it's reflected.
So we don't distribute that. We don't distribute that to the negative x squared.
Right, we don't distribute the 2 into the negative x squared. We would have to simplify the negative x squared first if we could, and then multiply it by 2. That's a good question. Any others before we look at vertex? No? Now, vertex is h comma k, and this is again coming from our a times x minus h squared plus k. The h value of the vertex comes from inside the parentheses for this one here, and k comes from outside. Now, looking at the vertex for this one here, the k value is a little bit easier to see because k is on the outside is exactly what it looks like, and our k value is negative 3. Now, the h value comes from inside the parentheses. It would be 0, indeed, because we don't have any parentheses, so it is 0. And it is possible for the vertex to be 0, 0. Because since we don't have any parentheses, we don't have this x minus h or x plus h, we don't have a value there. I mean, realistically, we could rewrite it as 2 parentheses x minus 0 squared. Don't need the plus. Minus 3. We could write it that way. We don't have to. It doesn't add anything to it. But it is showing that the h value is 0. Any other questions on this here? You ready for the next one? Let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation of 2 units up. So the first one we look at is vertical shrink. Well, vertical stretch and shrink, we can apply that transformation by using the a times f of x. This is how we can apply the vertical stretch or shrink. Now, the value of a is exactly the factor that we're stretching, or in this case, shrinking it by, which is, so we'll have 1/2 times f of x. Now, since we still have f of x, we didn't change anything inside the parentheses. We don't have 2x or x minus 4. We can just replace the function with what it's equal to. So f of x is equal to x squared. So we're going to replace f of x with x squared. Questions on any of this here? Questions on any of this so far? We're all good? If not, let me know. Now at this point here, we multiply the 2 together. So we're going to do the 1/2 times x squared, and 1/2 times x squared is x squared. Now we're going to call it h of x because we need a way to name the new function to distinguish it from the original function f of x. But so far, we have applied the vertical shrink by a factor of 1/2. Now we need to apply the next transformation, a translation of 2 units up. Now this here is going to be our h of x plus k. because this is going to be up and down. Now, on the previous slide, I called it f of x, but since we're not applying it to the original function, we're applying it to h of x. We're going to call it h of x plus k. Now, our plus k is the amount that we're moving. Well, we're moving 2 units up. So the value is 2, and it would be plus, it would be positive because up is the positive direction. Questions on how we've set this up thus far? Good with this here? Now we still have h of x, x inside those parentheses, which just means that we take the function h of x and plug it in for it here, which means we'll have parentheses 1/2 x squared plus 2. So we can drop the parentheses because there's nothing in front of them, telling us that we have 1/2 x squared plus 2. And we can call this g of x. Are there any other translations that we have to do? No. So the final function is this here. Now we do need to find the vertex for this function. So f of x equals y equals a times x minus h squared plus k. And the h and k values will give us the values of the x and y for the vertex. Now the k value is what we have added or subtracted to the function. So in this case it is positive 2. And the h value, do we have one? So it's 0. And that's it. Questions on any of this here? Are we ready for the next one? It's the last one with transformation that we'll look at today. Move that over a little bit. Almost. Nope. Missing it. There we go. Wanted to make that a little bit smaller, so yeah. So that way I'm not having to scroll way far down, scroll way far back up, keep going back and forth, and we can see the entire problem at once. It did give us part of the answer, but I don't think that's helpful. The transformed. Yeah. I don't think that tells us much. So let the graph of G be a horizontal shrink by a factor of 1/3 and a reflection in the y-axis followed by a translation of 2 units up. So again, we're going to do them in the order that they told us. We're going to do the horizontal shrink by a factor of 1/3 first, a reflection in the y-axis second, and then a translation of 2 units up of the graph last. Now, horizontal stretch and shrink, we denoted it by a f of a times x. This one here is a little bit different than the last two because we're actually going to have a value inside the parentheses. Now the value of a is coming from this 1/3, but yes, because it's a horizontal and it's going inside the parentheses, we have to flip it. Horizontal stretch and shrink, we have to flip that value, which means for us here, the a is 3. So we have f of 3x. And this is the first one we've had today where what's inside the parentheses for any of the functions here was not just x, it is 3x. So we changed the x in f of x to 3x, which means every x in the function is going to change from x to 3x. So what we have is, well, 3x squared. And if we had any other numbers with it, they would stay in place too. And then Now we could multiply this out, we could simplify it, but I'm not going to ask you guys to do that. And that's even true with horizontal translations left or right. We can leave it as x minus whatever the number squared. I'm not going to ask you to multiply and distribute it out. We can leave it as this here. If you do choose to square the 3x, which would give us 9x squared, that is fine too. I will take either answer. But any questions on the horizontal translation? So we got that one done. Reflection in the y-axis. Now reflection in the y-axis is going to be a h of negative x. H of negative x. And again, just like with the first one where we replace every x in the function f of x with 3x, here we're going to replace every x in h of x with negative x. So we'll have our parenthesis 3, but instead of x we have negative x squared. So we replace every x in h of x with negative x. Do we see what we did there? Yes? In the middle, yes. Because we do 3 times negative x, which is negative 3x. We still have the parentheses around the square. Because to simplify that, we would have to actually square the whole thing, the negative 3x. But we can leave it as negative 3x. For here, because we're doing 3 times negative x, which is our negative 3x. Any questions on this so far? Yeah. Now we need a way to name it, so someone give me a letter. Huh? G. You're good? G of x is this here. So we did the reflection, which leaves us with what? Translation of 2 units up. Yes. Because especially the up or down, we're just adding or subtracting that number to the end and we're good. If we do it by our notation, we would say g of x plus 2. Well, g of x is our negative 3x squared. We have plus 2. We can call this L of x. And that's our last translation. Now again, I'm not concerned about how we name the function, h of x, g of x, L of x, z of x. That's just a name. That's just a name for it. It doesn't really matter. I'm looking more at the function itself.
So when it's a reflection across the y, we're just going to put the parentheses in the 2.
Right, for this here, we'll have the parentheses in the square because we're replacing that x itself.
Okay. So we can square that.
Well, it would be 9x squared, yes. Because our negative 3x times negative 3x would be 9x squared, and we can have that. And that works because we only have a single term being multiplied by itself. If we had something like negative 3x plus 1 squared, this is not the same as 9x squared plus 1. Those are not the same thing because we actually have a middle term of 6x. Because our distributive property, if you remember back from Algebra 1, or when we have the square, you had to rewrite it next to it and then distribute all the way out. We would have to do that full process. But I'm not asking y'all to do that here. Now the last thing for this, we need the vertex, which is our h comma k. So a parentheses x minus h squared plus k. Well, the k value is.
Oh, so we still wouldn't have. There's no h.
There is no h. Yeah. Subtract an h. We could also add an h, either one, depending on what it is. Here it's still 0. Questions on this here? Now, all the ones we've had so far, we've not had a have a h value for the vertex. I'm just going to create a problem. Okay. So we want to find the vertex, our HK. So the one outside, our K value is 3. Now, if we remember inside the parentheses, it's x minus h squared, yes? Both the original form, x minus h, and the x minus 5. The x are the same, the minus are the same. So what is the value of h? It would just be 5. Mm-hmm. Yep. So if it was negative, it comes out as positive.
So it would still put it before the vertex.
So if I said x plus 5, the h value would be negative. Mm-hmm. Does that make sense? Yeah, because again, that's going with the left-right movement. Because our parent function, f of x equals x squared, the vertex is the point 0, 0. So here we're saying with plus 5 that we're moving left 5 and up 3, which means with our vertex we move left 5 for the x. Well, 0 minus 5 is negative 5. Up 3, we add 3 to the y, giving us negative 5, 3. Questions on this here? You have the rest of the time to work on the assignment. 3 through 11 odd, 17 through 21 odd, 27 through 29. Now on these here, you do not have to graph. Even if the problem says to graph, you're not going to graph them. But you need to describe the transformation for 3 through 11 and 17 through 25. It's asking just for the transformation. You describe it up, down, left, right, stretch, shrink, reflections, those there. For 27 through 29, you are still describing the transformation, but you also have to name the vertex, our vertex point.